Welcome to a special episode of our flipped videos. Today's topic is the scariest of all topics, atomic structure. Hey!
Hey, Mr. Carstone!
What's up?
We're just setting up the video equipment
Ready to record?
and doing stuff. Yeah, we're good. Yeah, we got it all set up, and I'm not crying. I have allergies. So let's talk about atomic structure.
Yes.
All right. Very
Sounds
proper
good.
subject.
So, quick review of atomic structure, of atoms. Atoms are the smallest unit that makes up all living and non-living matter, as you learned the other day. Really teeny tiny, itsy bitsy. They're smaller particles than atoms, but that do not exist as individual units. So those are going to be like your protons, neutrons, and electrons.
So you're saying that atoms are made up of protons, neutrons, and electrons.
True.
So atoms are a little bit bigger than them because it's like those are the little Legos that make up the slightly bigger Lego of an atom.
Exactly. And then you take a bunch of atoms and you put them together and you get molecules.
I see it in the picture right there. It talks about,
Yep.
it looks like protons and neutrons are in the middle.
Yep, and electrons are going, woo!
Ah, cool.
So as a review, protons are the positively charged particle. Neutrons are the neutral charge. They don't have a charge. Then electrons are orbiting around the outside. Now you see all those little numbers there. You don't need to memorize those, but what those are atomic mass units. It's actually a mass that they use to measure how much mass these particles have. Now a proton and a neutron, they have something that is one atomic mass unit. That's
Yeah.
how much they have a mass of.
So they weigh one.
One.
Yeah.
Right.
Now electrons are 1,836th
That is
of a
crazy.
So-
atomic mass unit. So in order to get the mass of a proton, you'd have to put together 1,180 or 1,836 electrons. Although there are some people that think it might be even smaller. We actually don't have the ability to measure the mass of electrons.
So they
They're
figured that
so
out
small.
mathematically?
It is the smallest thing that we know of.
Awesome.
So, when we look at the masses on the periodic table, Mr. Karnstead, does the electron get figured into that since it's got such a teeny tiny mass? I don't get it.
I'm guessing no. I'm pretty sure the atomic mass is really only taking into account the number of protons and the number of neutrons.
That's
Okay.
true, because if you look on there, protons and neutrons have a mass of 1. The electron is so tiny, it's effectively, mathematically at least for us, it's a mass of 0.
Okay.
It's so tiny.
Got it.
Cool. So one thing that we're eventually going to move on to is something called a Bohr model. Okay.
Woohoo!
Now, if you remember, you looked
Niels
at
Bohr.
yeah,
Niels Bohr. Niels Bohr.
We'll do that later at the
you
party.
studied a scientist named Niels Bohr, and he developed this model for how an atom looks. Okay. So if you notice, the P and the N in the middle, they stand for proton and neutron, and the proton and the neutron are in what we call
The
nucleus.
nucleus.
Very
The
good.
nucleus means the center of something.
And it's teeny tiny.
now. Orbiting around that nucleus are electrons.
Even teeny tinier.
And you'll notice they're in two different circles. That's because you have two different energy levels, or you can have more than two. Just
Yeah.
in this picture, there are two.
Fair enough.
I like to sometimes refer to the energy levels as shells, although that's not
Yeah.
a very
We might hear
scientific
them called
orbits.
orbits,
Or
too,
orbits,
because
yeah.
they
Orbits,
orbit
too.
like planets around the sun.
All right.
Exactly.
But before we get into how to draw Bohr models, we actually have to look at how to figure out how many protons, neutrons, electrons there are
Exactly.
in something. Okay.
So one of the first things you got to know to be able to draw Bohr models, or even just to kind of know where things are located, is you have all these different electrons, and there's a certain set of electrons in every atom that are a little bit more important than the other ones. And those would be the outermost ones, which are called valence shell electrons. The reason why they're more important is because they're on the outermost rings. So if you look on the diagram there, those 6 that are on the very far outside part, those are your valence electrons for oxygen. And they're so important because the valence electrons are the ones that are actively involved when you combine stuff. So if you remember, if you take that magnesium, we burned it, right? And you've got the magnesium oxide, that white powder that was formed. The oxygen and the magnesium, they went like this and formed together because their outer shell electrons were interacting with each other.
So
the
you're
other
saying-
electrons are there, they're just not actively involved in the bonding process.
So you're saying those two electrons that are on that first shell, they weren't involved in that chemical reaction?
No.
Correct. They're
Okay,
still
it's
there.
only the 6 on
Right.
the outside.
Think of them again like Legos. The electrons on the outside, and by outside we mean the valence electrons. Those are the guys that do the chemical reactions. They snap together like Legos with other valence electrons from other atoms.
Yep.
And when you combine these different atoms together, if they were elements, you've now made a compound. And we
Okay.
talked about compounds and other pure substances before and how they're related to elements.
All right, so the ones that are circled there, those are the valence shell electrons.
Yep.
Those ones, I mean, they exist.
Right,
Don't make that
and they're
circle
important.
across a
Right,
bit,
and
but
one thing
they're
make
not
a-
valence shell electrons.
Yeah, and make sure we're important. It's not that they're not important, because they are important for the atom. Just in terms of bonding, we don't
They
tend to
don't
look
do
at those.
chemical
Right.
reactions.
Right.
On our level, at least.
So let's take a step back and talk about, you look at the periodic table, how do you actually figure out this information? Okay? So we're going to take a look at carbon, which is one of my favorite atoms. The first thing you got to figure out is how many protons an atom has. Now what you do is you look at this number that's above the symbol for it. I'm doing C backwards, I think, for the camera. But so you have that C, and above that you'll have a number. That's called the atomic number. The atomic number always says how many protons that atom
Yes.
has.
And
So-
that's important because the proton is what actually identifies the element.
Yeah.
So I can't have a carbon with 7 protons?
No,
No,
because then
because-
you would actually have anybody?
Nitrogen.
Nitrogen.
Good
So if
choice.
you added a proton, if you guys look at your periodic table of the elements, you'll see that the element just to the right of that has a little 7 over it and an N. That N stands for nitrogen.
Right.
It says, hey, 7 protons is nitrogen, 6 protons is
Is
carbon.
carbon.
Can't mess with that number of protons, but there's the other parts we can.
All right. So now you'll see a number that actually has some decimals below that. And you want to explain what that is, Mr. Harkins?
Yeah, what that is, that's the atomic mass, or sometimes you'll see it where they talk about average atomic mass. And what that number is, you'll notice it's bigger than your number of protons up there that you have, the atomic number. What that is, the atomic mass, is the number of protons and the number of neutrons in that atom added together. So if we can see up there that carbon has 6 protons, if you take, let's round it and say 12, 12 minus the 6 says that we still have 6 neutrons. Because if you add protons and neutrons together, you get that atomic mass.
And that works because we don't count the electron for mass?
You don't count the electron. The electron effectively has a 0 mass. So again, we're discounting that guy. He's great for chemical reactions, not so much for seeing what the mass of this guy is. Now, the reason we have a decimal on there, guys, and we can go into this more in class as well, is because that's an average. And every time you average something, you're rarely going to come up with a whole number. So we're looking at an average mass of all these different things called isotopes, which we will get into later.
So, and then I think Mr. Harkins was kind of talking about this.
Yes.
The mass number is when you round that average atomic mass up or down to that nearest whole number.
Yes.
So the most common carbon atom would be 12.
Yeah, carbon 12.
Would have 12
Neutrons and
neutrons
protons,
and protons in the
together.
nucleus. So that's what we're actually going to use when you want to figure out how many neutrons you have.
Yep.
What you do is you take that mass number, which is 12, subtract the number of protons, which was,
6. You can see that in the top left corner there.
and then you get 6 neutrons.
6 neutrons. Math even I can do.
Okay.
Would you like to take this?
So, and here's a little cheat sheet for how you actually calculate all these different
Yeah.
types.
These are important. This will help you a lot.
So, in a neutral atom, and what we mean by that is there's no charge. The last thing we haven't talked about is electrons. The electrons are always going to equal the same as the protons.
Yeah,
okay?
because a positive and a negative cancel each other out. So you got one positive proton, one negative electron. Those two guys cancel each other out, and you've still got a charge of 0, a little electrical potential of 0.
Think real basic math. A proton is +1, electron is
Minus
-1.
one.
1 minus 1 is?
0.
0, which is
Yep.
neutral. All right, so next one we're going to move on. Now that you know a little bit more about the basic atomic structure stuff and how to find all these protons, neutrons, and electrons, we're going to show you one of the classical models for showing how the atom looks. Now, one thing I want to preface this. The Bohr model is great as like a two-dimensional like kind of schematic or drawing of it. In actuality, that is not what the atom really looks like, but for all intents and purposes for us, that's what we're going to run with because it still is used today because it gives you a really good idea of where stuff is located.
So, and I put a picture up there. That's Niels Bohr, who it's named after.
Yeah.
And you'll notice, you might recognize the guy that he's hanging out with in that picture on the right.
Einstein.
He was very good friends with Einstein. They just-
Relatively genius type man.
Yeah.
Yeah,
They just like to hang out and talk science and stuff.
Yep.
He also played, Niels Bohr also played professional soccer. For
he
a pretty
did.
good
Did he really? Look at that. The
Decided
soccer
science was
tie-in.
cooler though.
Yep.
I will just guess with that forehead, too. He probably headbutted the ball a lot.
He was a goalkeeper.
Yeah, look at that thing.
All right.
Big hands.
So here we go into Bohr models. Now there's 5 steps, and then I'm actually going to demonstrate how to draw one.
Cool.
Yay.
So the steps of drawing a Bohr model are first figuring out your protons, neutrons, and electrons,
Which we just
is
covered.
kind of a process, but we just talked about that.
Yep.
In the nucleus, so you notice how there's a spot where it says protons and neutrons. Now you might not always get those blanks to fill in. You might just have to draw it yourself and
Yep.
write, there are
Yep.
so many protons, so many neutrons. Now, on the first valent shell, there are always only two electrons.
Yep.
So that first little circle around the nucleus, you can only put two electrons.
Okay.
No more.
So keep in mind, you're going to be counting your number of electrons ahead of time.
Yeah.
So if you only have like one electron,
You just put one
you only
there.
put one. Okay, you're only putting the amount of electrons that atoms should have.
If you have three, then do you just put the first two on that first shell and then put the third one on the next shell
Yep.
out?
And then you
Indeed.
keep on going. You can only
I
put
get it.
8 electrons on the second shell,
Ah.
and then you can put 8 electrons on the third shell. And then it gets more complicated after that. But we're actually not going to go into really big
So
atoms.
Right, we'll
2,
stop
8, 8. That's the number that we have to remember for these Bohr models, right?
Right.
It's
2,
2 on the
8,
first
8.
one, 8 on the
2,
next,
8,
on the
8.
and then 8 on the next.
2,
So
8,
2, 8, 8.
All right.
Got it.
8.
So I'm gonna
Start
demonstrate-
chanting now. 2, 8, 8.
We will do it a lot.
I'm going to demonstrate how to draw one of these real quick.
Okay?
Okay?
All right, so we're going to draw a Bohr model for magnesium. Okay, so first you got to find out the periodic table. Now, there's a few important pieces of information we need to figure out before we draw our Bohr model. We need to know the number of protons, the number of neutrons, and the number of electrons. Okay, so protons is really easy. All you do is you look at this number, which is called the atomic number. The atomic number is always going to stand for the number of protons. Every single element. That's what the atomic number stands for. Now, neutrons gets a little tricky. What you need to do is you look at this number called the average atomic mass. Okay? Now, the average atomic mass is a little complicated. What that is for whatever element that is, scientists have taken all of those atoms of that type and they've averaged the number of protons plus neutrons. Okay? Now, normally what you do is you to figure out what your average magnesium atom is going to look like, you take that number and you round it to the nearest whole number. Okay, so this 0.31 is lower than 0.50, right? So you round it down. So now you have a whole number of 24, and that stands for your number of protons plus neutrons. So to figure out your number of neutrons, what you do is you take your protons plus neutrons, subtract the protons out, and you get 12 neutrons. Okay? Now I should point out that you're going to see some elements where a lot of the time the neutrons are going to be the same as the number of protons, but if you were to do that for every element in the periodic table, you would find out that's actually not that common. Okay? So this is not a usual thing. Now finally, electrons. Now the way you find electrons, in a neutral atom, you're going to have protons and electrons that are canceling each other out so that the overall charge is 0. What that means is for every proton, there's an electron. So you can have 12 electrons. This isn't the case with an atom called an ion, but we'll discuss that more later. Now let's move on to the actual Bohr model. Now there I have my number of protons, my number of neutrons, my number of electrons. Remember, this is magnesium that we're drawing. Now the first step to this, really easy. All you do is you write in your number of protons and your number of neutrons in the middle of the atom, because that's where the nucleus is. That's where the protons and neutrons are. Okay? Now, the more complicated part is actually filling in electrons. Now, if you remember from previously, the first shell is going to have 2 electrons in it. The second shell is going to have 8. Okay? And then the third can also have up to 8. So we need to start filling in our 12 electrons according to this. So our first shell, we're going to fill in our first 2 electrons. So we've taken 12, we've put 2 in there, we've got 10 left. Okay? So let's fill those into the second shell. We got 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I've taken another 8 out, so I still have 2 electrons left. So I'm going to fill those in. 1, 2. And now we have our 12 electrons. We are completed with our Bohr model. Yay!
All right.
That was
That-
awesome.
That was
Good
a
video?
good job, Mr. Carnstead.
Dead on, you rock.
All right. So that's it for today. Have a happy Halloween. And if you watch this all the way to the end, please draw a picture of a jack-o'-lantern in the upper right corner of your notes so we know that you're paying attention.
Yes.
Wow.
Scientia Frenti!